Let's see, which of the programming examples in our big family of examples have we not heard very much from recently? Well, I guess it's been a couple of weeks since we dealt with the credit card class, so maybe it's time to pay it a visit. See what's happened in the meantime, catch up on things. So just like in week 6, we originally saw the credit card class in the example of constant member functions in week 6. Just like in week 6, we've got our credit card class has an unpaid balance. That is the amount that you owe on the card. There's also a credit limit. And the basic idea is that's the total amount, the maximum amount that you're allowed to borrow. We mentioned at the time, though, that I guess it is possible for the unpaid balance to actually be greater than the credit limit in certain cases. One example being if you owe a certain amount and the credit limit gets lowered to below that amount, or maybe interest accrues or something. So these are sort of independent. But the idea is as long as the unpaid balance is less than the credit limit, you can keep charging stuff to the card. And the rest of the credit card class is pretty much the same as it was when we left it in week 6. So you can construct the card with some initial credit limit, you can get the unpaid balance, you can get the limit, you can get the amount of credit you have left. And then there are these two functions to charge an amount to the card and to repay some of the balance. And all I've really done to the example in the meantime is make the charge and repay functions virtual. I haven't made the functions to get the unpaid balance, the credit limit, and get the remaining credit. I haven't made those virtual. And I have a good reason for that, which is that I've decided to keep the unpaid balance and credit limit members private. So the idea here is that maybe I want to define my own subclass of the credit card class that adds some behavior to charging and repaying, but I do want to sort of lock down the underlying idea of the transaction. So what the unpaid balance is and what the credit limit is, I don't necessarily want child classes modifying those things or working with them directly. And by the same token, I don't want them overriding any of the functions that provide that information. But I don't mind if the child classes override what it means to charge or repay funds on the card. And then down here, I've started off a class called Points Card. So the idea being this is some fancy credit card where you can earn points. And I'll show off what's happening in main quickly before I do that. So I've created a credit card C1 and a points card called C2. I'm going to call the same functions on both of them to make the same sequence of charges, but I want to check how many points I've accrued on my points card. And obviously, banks that issue these points cards knows that they're a very clever gimmick because people do, for some reason, get obsessed about these points that are basically worth nothing and somehow make people forget about the predatory lending scheme happening underneath. But that's something we can talk about in the office hours. Come visit, we'll talk about that. In the meantime, suppose I keep checking the number of points on the card. And then also suppose the card provides some gimmick where I can redeem these points that are almost worthless for some token amount of money and then pay down my balance. So what I want is to be able to develop points card as an extension of the regular credit card class so that I can still charge the card as normal and I can still print the card out as normal. It is true this print card details function is a little bit contrived. I probably would make this a member function that I might override to print out the different kinds of cards. I'm doing that here to demonstrate, of course, that I can pass in points card as a credit card. I'm demonstrating that idea that points card is extending the credit card class, a concept that now that we're at the end of the week, we can give a name to. This idea that points card can function as a credit card, can function as one of its base classes in any context where the base class is needed, that actually has a name. That is called polymorphism. And we can say that the points card class is polymorphic because it can choose to represent itself as a credit card, as a base credit card object in contexts where that makes sense. Okay, so what's the points card class all about? Well, the idea here is that we have a constructor. So if I construct a points card with some initial credit limit, well, I'll initialize the number of points on the card to be 0. Otherwise, I'll just defer to the constructor for the base class that takes that initial credit limit. I'll pass that along because I know the points card class, I'm not really in control of the credit limit. That's something that the base credit card class handles itself. I also have this function getPoints, which I hope is self-explanatory, and I have a function called redeemPoints. And this bank's gimmick is if you manage to accrue 1,000 points, you can choose to redeem them for $10 against your balance. If you don't have 1,000 points, you can't try redeeming them. And then if you do have 1,000 points, I'll just call repay to repay $10 of the balance. Now, it's possible repay might fail. And this is a good time to bring that up. So the repay function only allows you to repay an amount that is actually unpaid. So if my unpaid balance is $5 and I try to repay $10, I'm not allowed to do that. So this time, unlike in week 6, there actually is a protection against that. The bank won't take any more money than you actually owe, which is sort of nice, sort of out of character for a bank. And so here, I try to repay $10, and then it's worth considering what happens if that fails. So if the repay function won't do it, so if the repay function throws an exception, then this function, redeem points, will end. And that means that line 82 is only ever reached if the repayment succeeded. So I only ever modify the number of points if I was able to repay it. So somebody with an outstanding balance of $5 who tries to redeem points will get an exception thrown, but their points won't get modified, which I think is the correct way to implement this. I think that we shouldn't take away their 1,000 points unless we actually do deduct $10 from their balance. And that, I claim, is what this function is already doing. We don't need extra logic. We don't even need an if statement to check if there are $10 on the balance. The exception thrown out of the repay function takes care of that for us. Okay, but that's not the point of the video. The point of the video is to make sure that somebody with a points card actually earns those points. And so the gimmick we're going to use is you get 1 point per dollar spent. And that means if I have a transaction for some odd number, so if I spend $1.87, I just get 1 point. So, this bank might be a little bit more humane than others, but it's still, still not going to give you full credit. So, in general, we just we truncate the number of dollars that you spend on each transaction to an integer and then give you that number of points. And I'll try running the code as it's written. The code is actually going to fail. We're going to get an exception thrown, basically because the points card currently has no facility to actually earn any points, but just to show off the sort of structure of the output that we want. So in part 1, I print out that I perform 2 transactions, and then I try and print out the number of points on the card, and it has 0 because I haven't actually implemented the facility to earn points yet. I then print out C1 and I print out C2, and we observe that their balance and remaining credit is the same because the underlying credit card class is still doing all of the usual work it's supposed to. I then print out the number of points again, and it still has 0 points. And then I try and redeem points, and obviously that fails because there aren't any points to redeem. So the task for the video is I need to write the function that actually allows me to earn points. So how do I do that? Well, I would like it that we want to, convey this abstraction of this just being a regular credit card. So I suppose you hand your credit card to the merchant, wait a minute, which nobody does in 2022. You tap your card against the card reading machine and it just charges the card. I don't think a points card should need special treatment to be able to earn points. But that's a perfect application of overriding. What I could do is I could override the charge function. When you try and charge a points card, it happens to also, in addition to doing the charge, it also adds some points to your total. So I think that's a great application for overriding. So we'll override the charge function to add that functionality. I'll just go steal the function signature from up here. So here's the charge function, and we'll just paste that in. And then I'll put the word override to signal that I am consciously overriding the function. Okay, so what do I have to do? First, I have to charge the card as usual. And I'm going to leave that. I'm going to actually, maybe we'll number the steps. There's step 1, there's step 2. I'm going to say step 1 goes here. I'm just going to leave step 1 for now. And then, assuming that step 1 succeeded, I now want to add some points to my total. So the number of points I add is the number of dollars you spent with the fractional part omitted. So it says rounding down, but I'm going to read that as if you spend a number with a decimal point, just chop off the decimal point. So basically convert the amount to an int. That's the number of points you earn. I think that's pretty easy. I have this variable called points. I'll just set points. I'll just add to points. Points plus equals the integer version of the amount. We'll just truncate it down to an integer. Okay, great. So now I've got a way of adding some points to the card when you charge an amount. I'm doing that as step 2 and not step 1 deliberately. Because what if step 1 fails? What if somebody whose card is maxed out tries to make another charge on the card? We don't want them earning any points for that if they don't actually charge the card, if the charge fails. So just like in the redeem points case, we're going to assume that if an exception gets thrown when we're trying to charge something, we never get to line 77 and we never have to worry about it, which I think is a pretty elegant way of doing business. The question is, how do we do step 1? So here are our options. We are overriding the charge function. So I suppose I could reinvent the wheel. I could try and duplicate all of the logic of the charge function in points card. I could just copy and paste this. Now, it turns out that won't work. Now, because if it did work, you could always argue that, well, there is a way of doing this, Bill. Why should we learn something new? Well, I've designed an example where you have to learn something new. I'm so sorry. You're going to have to learn something today. I'm not actually able to do that. I suppose I could try and reinvent the wheel. If I want to override the charge function with my own version in points card, I could just take this entire set of code and bring it down. The problem is, if I tried that, it wouldn't work. And actually, well, why don't we try it? I mean, let's just see what happens. I'll charge the card as normal. There are lots of other reasons this is a bad idea, but I want to show that it's just impossible. The compiler won't let me. And the issue is that the variable unpaid balance is private. Credit card owns that. The parent class credit card owns unpaid balance, and I'm not allowed to look at it directly. I can ask for it, but I can't modify it. So what do? Well, what I'm doing here is overriding the charge function. I'm defining my own specialized version of the charge function in points card. But actually, I'd benefit a lot from being able to also sort of recycle the charge function that came with the credit card class. In other words, I don't just want to replace the charge function in points card. I want to extend the charge function in the parent class and add a little bit extra to it. So what I want to do now is call the charge function that my parent class already has. So how do I do that? And there is a way of doing that in C++ and virtually every other object-oriented language. It's something that is a very common application. You want to define your own charge function that just adds a little bit of functionality on to the charge function that came with the class, the charge function you inherited. The way we do that is not the obvious way, because maybe we can see how that would make no sense. If I just write charge of amount, so line 76, the compiler will say, wait, what do you mean by charge? Do you mean this? The function you're currently writing? Are you trying to recursively charge the card? No, I'm not trying to do that. I'm trying to call a different function in a different class. I am in the points card class. I want to call the charge function in the credit card class. I don't want to call the charge function in the points card class because that would be circular logic. And so you write this. Notice the colon notation. This is a very unusual use of the colon notation, but it's a way of disambiguating. So we know already I'm allowed to call any member function I want from inside a member function. An example being inside of redeem points, I call repay. I just call it by name because it's a member function, and I can treat all of the other members of the class like they're just local to the class. Similarly, up here in the example we concocted in week 6, I call get credit limit inside of get remaining credit. No problem. I'm allowed to use the other members of the class. I want to do that down here. If I just write charge, though, the compiler gets confused and says, but which charge function? Do you want the one you're writing now, the one that's in points card, or do you want the one you inherited? So in order to disambiguate that, I have to say that I want the charge function that I got from my parent class. Call the charge function from the credit card class. Explicitly indicate which member function called charge you want to use. And you have to do it that way if you're overriding the charge function yourself. So I'm saying when I override the charge function in the points card class, first call the charge function that came with the credit card class, and then do this operation on line 76. So we'll try that. We will see that it does compile, and then we'll try running it. And then we'll skim through the output. Okay, so I'm going to scroll down to main so we can see what main is trying to do at each step. So I create two cards. One is a points card, one isn't. And then I charge both cards the same thing. So I put these two charges on C1. I put the same two charges on C2, and I check between charges. When I charge 701.87 to C2, it only ends up with 701 points, which is the correct behavior. And then I charge $610, and I end up with 1,311 points, which also looks good. The total balance of the card when I'm done is 1,312, because I do store the number of cents when I'm storing the balance. That doesn't factor into my points calculation. And then in part 3, I print out the number of points again, I guess just for certainty. And then I try redeeming some points, and I print out the number of points after that. That's part 4. And we can see after I redeemed points, I only have 311 points left, so I did successfully redeem 1,000 points, and I'll notice that my balance has been deducted. So I have lost $10 of outstanding balance. I've repaid that. So I think my points card is working correctly. And this is a very common application where you define a subclass that makes some tweak to behavior in the parent class. It doesn't completely replace the behavior, it sort of augments it or it calls it conditionally. And in general, if you want to use the charge function in the parent class, you would do this. And it works just like any other function call. If it were the case that the function in the parent class returned a value, you could just take the value and assign it to a variable or something. In this case, the charge function doesn't return a value. But if ever you need to call a function from your parent class explicitly, you want the one in the parent class, not the current class, you can use the : notation to disambiguate.